So same with the geometric one, we're going to be calling T1 as A. T1 is term 1, or basically the first number. Okay, so we're also going to call that as A. So hope you're used to having A as our first number. Okay, so if A is our term 1 or our first number, the next number in our sequence is going to be A times R to the power of 1. Now basically here, we're multiplying by the same common ratio. Okay, instead of common difference, we're going to be calling it the common ratio since we're multiplying. So R is going to be our notation or our symbol for common ratio. Okay, so we've got A times R, alright, and the next number in the sequence will be called term 3 or T3, or the third number, which is going to be A times R squared. Okay, and then the fourth number will be term 4, T4, which will be given by A times R to the power of 3. Okay, I'll give you an example here, guys. Let's say 2, and then 4, 8, 16. Let's say this is the sequence. So what do you see common? It's from here to here, we simply multiplied by 2, didn't we? And then to get here to here, again, we simply multiplied by 2. And again, to get here to here, we simply multiplied by 2 as well, didn't we? So therefore, guys, basically, term 1 here is going to be 2, so A is 2. And then term 2 is going to be A times R to the power of 1. R is the common ratio, in which this case it's 2. So to get to the next number, we've simply multiplied the first term, A, by R, which is 2. Okay, so we've got the second number, 4. Alright, and then to get the third number, T3, we simply multiply the first number 2, A, with R squared. R squared is going to be 2 squared, isn't it, since R is 2. So simply multiplying 2 times R squared, 2 times 2 squared, which is going to be 8. Alright, so I hope you see the pattern after I give you an example like that. So basically that's the kind of thing. Alright, so I hope that makes sense. That's basically it. And then to get Tn, we don't know what n is. Depending on what n is, Tn is going to be A to the power of R to the power, A times R to the power of n minus 1. Okay? So it's going to be, the power is going to be n minus 1. It's always going to be 1 less than this n here. Okay, see here. 3, which is the power of R, is 1 less than 4, isn't it? And see here, 2 is 1 less than 3, and of course 1 is 2 less than 1. So that's why the power here is n minus 1. Okay? So that's it. That's our geometric sequence. That's the kind of thing will happen first term, second term, third term, etc. This is our formula derived from that kind of pattern. Tn equals to A times R to the power of n minus 1, which is basically this one here. Okay, and again, A is the first term, R is known as the common ratio. Okay, so we multiply by R to get the next number. Okay, so yes, you have to memorize this, guys. Trying to remember this because we're going to utilize that throughout all our questions. So have a look at that, guys. And let's try to apply that onto our questions. So before I go to the questions, I want to show you one more example of a geometric sequence. Something like this. If term 1 is 3, okay, let's say term 1 is 3, and then term 2 would be 3 times the common ratio to the power of 1, right? They give us that 2 is 2 to the power of 1. So again, I'm assuming that the common ratio is going to be 2. So 3 times 2 to the power of 1 is simply 6, isn't it? And then term 3, we go 3, which is the first number, times 2 to the power of 2 this time. That's going to be 12. And then, of course, term 4 will be 3 times 2 to the power of 3, right? So therefore, that's going to be 24. Can you see that? It's a pattern 3, 6, 12, 24. See, we're multiplying by 2 each time. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. Okay, so it's a geometric sequence. Now have a look at here. Depending on what n is, we don't know what n is. If it's n, if n can vary, Tn will just be 3 times. 3 is the first number A, 2 is our common ratio R, and because we don't know what n is, the power is simply going to be n minus 1. Okay, always 1 less than this n here. Okay, so that's the kind of pattern you can think of as one of those geometric sequences. Okay, so I hope you get some idea of what that is now. So let's try some questions. So starting with question 1, write the nth term of the sequence 1, 2, 4, 8, etc. Okay, so the list goes on. So we're going to write the nth term. Okay, so we're going to write our sequence in terms of n. How should we do this? Well, I'm just going to apply my geometric sequence formula, but before that I want to know what a is and r is, basically the first term and the common ratio. A is going to be 1 because that's the first one on the list, so that's our first number. Okay, so that was pretty simple. A is going to be 1. R, our common ratio, we're going to think about this. 1 times what makes 2? Well, simply 1 times 2 makes 2, doesn't it? And then 2 times what makes 4? Obviously it's going to be 2, isn't it? And then 4 times 2 is also going to be 8. So therefore the common ratio is going to be simply 2. Okay, so have a look at that by looking at your sequence. So that's what A is and that's what R is, 1 and 2. So we know what A is, we know what R is, we can just use it into our AR n-1 formula. Okay, A is 1 times R is 2 and then n-1. Because it says find the nth term, we're going to put it in terms of n. Okay, and then that's it. Okay, and 1 times anything, okay, it's going to 1 times 2 to the power of n-1 is going to be 2 to the power of n-1. So basically I'm just going to write Tn as 2 to the power of n-1. Okay, and that's it. That's the answer to question 1. So it's actually quite simple. All we're doing was apply our formula. Okay, AR to the power of n-1. Alright. So with these ones as well, always look for your first term and your common ratio, okay, because that really helps out. Okay, so that's question 1. Have a look. And that's in terms of n. So this also can be a general term or general formula, okay, to find the nth term. Okay, so that's question 1. Let's move on. Question 2 says write the nth term of the sequence 3, 6, 12, 24. Okay, so this time this is a sequence, and again it wants us to find the nth term. So we're going to do our similar method as what we did in question 1 with a different sequence this time. So again, guys, think about what your A is going to be, what your first term is going to be, and your R, your common ratio. That's what it's going to be. A is going to be 3 because obviously 3 is our first number and that's the first one on the list. So therefore the first term A would just be 3. R, which is a common ratio, let's have a look. 3 times what makes 6? 2. 6 times what makes 12? 2. And of course 12 times 2 makes 24, so the common ratio is always going to be 2. That's why it's a geometric sequence, okay, because it's multiplying by the same number each time to get the next number. Therefore R is going to be 2, okay, which is the common ratio that we found. Okay, so we've got A, we've got R. Okay, we can just put it into our formula now, just like that. That's it. So we're going to put it into our A times R to the power of n-1 form. So it's going to be A, which is 3, times 2 to the power of n-1. Again, it's going to be in terms of n because they want us to find the nth term. Okay, and that's the answer to question 2. So again, it was quite simple as long as you remember the formula. Alright, and one thing I want you to be careful, guys, please don't make a mistake by saying this is equal to 6 to the power of n-1. That's definitely wrong, okay? You can't multiply these two numbers together. Okay, that's our simplest form. Alright, I've seen some people make mistakes with that by accident, so I'm just informing you guys. Okay, so that's the simplest form. Don't go ahead and make that look like 6 to the power of n-1 because that's not true. Okay, alright, so that's question 2. Hope that one makes sense. Again, all we did was apply the formula by finding our first number and the common ratio. Alright, so let's move on to question 3. Write the nth term of the sequence 3 over 2, 9 over 2, 27 over 2, etc, etc. Okay, so again, it's the same kind of question as asking for the nth term. Alright, but this time again we've got another different geometric sequence. So have a look at this, guys. This time it's fractions. Yeah, I don't really like fractions, but let's see. Let's see what the first term is and the common ratio is again. So I hope you can see that the first term is definitely going to be 3 on 2. okay, because that's the first one on the list. So A is going to be 3 on 2. It says R is 3. Let's see. See how the denominators are all the same? So obviously we're not multiplying by a fraction since the denominator is unchanged. So I guess we're multiplying something to the numerator by a single integer. So 3 over 2 times what is 9 over 2? Well, because the denominator is the same, let's not worry about the denominator. 3 times what makes 9, guys? 3. Okay, 3 times 3 is 9. So simply we multiply 3 to get 9. So 3 over 2 times 3 is 9 over 2. And then 9 times 3 is 27. So again, we're multiplying by 3. Okay, so 9 over 2 times 3 is 27 on 2. Okay, so that's why 3 is our common ratio. All right, can you see that? Okay, so that was pretty simple again. A is 3 on 2, R is 3. We found those two important factors. Now what I'm going to do, just put it into our formula just like this. So it's going to be 3 on 2 times 3 to the power of n minus 1. 3 on 2 is A, 3 is R to the power of n minus 1, because again we're going to put it in terms of n. Okay, let's see if we can simplify this down to something like this. Okay, look guys, basically this, the reason why we have something like this, for those who are wondering, 3 over 2 times 3, oh wait, I'll put it all on the numerator. So have a look, 3 over 2 times 3 to the power of n minus 1 is going to be the same as 3 times 3n minus 1 over 2. I just basically put 3 to the power of n minus 1 onto the numerator with a 3 as a single fraction, so I can make it like that as a single fraction. Now look, this 3 is 3 to the power of 1 basically, isn't it? Yeah? So basically guys, this is going to be, see how the base is all the same? It's both 3. So what do we do if the base is the same and we're multiplying? We simply add the indices, don't we? Hope you haven't forgotten that. When the base is the same and we're multiplying, we simply add the indices. So what I'm going to do is add these together like this, 3 times, 3 to the power of, 1 plus n minus 1 over 2. Okay? Now 1 plus n minus 1, we don't really need the brackets, but I just put it there. 1 plus 1 minus 1, that cancels. It's going to be 0, so we're left with 3 to the power of n only. So we have 3 to the power of n over 2. That's what we have there basically. It's simplified from putting that all into a single fraction. Okay, so that's the answer to question 3 basically. So if you can simplify, always make it into a simplest form. Okay, always try to make it into simplest form, because that will be your final answer and you'll get full marks for this one. Alright, so that's the answer to question 3. Have a look at that. And don't forget to apply your index laws here, okay? That's also very important. So that's it, that's question 3. So Tn equals to 3 to the power of n over 2. And that's the answer. Have a look. Okay, so let's move on. Okay, question 4 says write the nth term. So again, it's asking us to do the same thing, find the nth term of the sequence 5, negative 10, 20, negative 40. Okay, this time we've got negative numbers, so maybe you're kind of wondering what we should do. Basically, we're still going to do the same thing, find A and find R. Okay, find the first term and the common ratio. So again, common ratio is going to be 5, which is the first one on the list, so that's pretty easy to find. Now it says R is going to be negative 2. Have a look guys, 5 times what makes negative 10? Negative 2, isn't it? 5 times negative 2 makes negative 10. And then negative 10 to 20. What do we multiply to negative 10 to get positive 20? Okay, it's positive 20 and this is negative 10. So again, if we multiply negative 2, so negative 10 times negative 2 makes positive 20, since negative makes positive. Okay, so I'm not even going to bother doing the next. It's obviously just going to be negative 2 as our common ratio. Okay, so yes, your ratio can be negative. Okay, so don't worry if you get a negative number, that's still fine. So we've got A, we've got R. Just put it into our formula now, just like this. There's going to be A times R to the power of n minus 1. A is 5, R is negative 2. to the power of n minus 1, and that's your final answer. And guys, don't make the mistake of multiplying these two numbers together and make it negative 10 to the power of n minus 1. That's completely wrong, okay? That does not make sense, so leave it like this and that will be your final simplest form. Okay, that's question 4. So again, it was pretty easy because the only difference it was the sequence was a little bit strange because it had negative numbers, but as soon as you find the same common ratio, it all makes sense, doesn't it? Yeah, so just remember you can have negative ratios, so just remember that. So that's question 4, that's the answer. Alright, so again, we're just applying into our formula to make sure you can remember our formula by now. A times r to the power of n minus 1. Okay, that's Tn. So that's question 4. Question 5. If the first term of a geometric progression is 4 and the common ratio is 3, which term is equal to 972? Okay. The first term is 4. Common ratio is 3, so this time they give us the first term and common ratio, so we don't have to go looking for it. So 4 and 3, and we want to find which term. So what's the term n with that's equal, that makes these 972? Okay, which term is 972? So what I'm going to do, well, basically I'm just going to, first of all, look, A is 4, R is 3, so I'm just going to put that as A and R, so we know what we're going to use into our formula. So it's given A is 4, R is 3. Let's put it into our formula basically. 4 times, because A is 4, 4 times R, which is 3 to the power of n minus 1. We want to find the value of n for which the term is 972. So that's why I let it be equal to 972. Okay? So then just go for it. Look for n. Find what n is. Let's solve it algebraically. So what I'm going to do, 3 to the power of n minus 1 is going to be 972 divided by 4, right? Basically we're dividing both sides by 4. So it's going to be 972 divided by 4, which is simplified to 243. Okay, 972 divided by 4 is basically 243. Now, 243, okay, try to do some trial and error with your calculator. You find out that 243 is 3 to the power of 5. Okay? And the reason why I wanted to have 3 to the power of something is because, see, this is 3 to the power of something as well. So if I make the base the same, then the indices would be the same, right? If they had the same base, then the indices would be the same. Okay, so that's why I've made 243 into 3 to the power of 5 as a base of 3. Okay, now you can see that the base is same, 3, so therefore the indices must be the same. So n minus 1, which is the index of this, is that. And the index of this one is simply 5, so they're equal to each other. Solve for n, guys. Move negative 1 over to the other side and make it positive 1. So we have 5 plus 1, which is simply 6. Okay, so therefore the 6th term is 972. Okay, that's how you can put it. The 6th term, because n is 6, is 972. Alright, and that's the answer. That's the answer to question 5. Alright. So I hope that wasn't too bad. Sometimes they do give you questions like this, okay? This is a usual common exam type question, so have a look, but it's not too difficult. All I did was apply my formula again, okay? A to the power of A times R to the power of n minus 1, sorry. Okay, so that's the answer to question 5. Hope that makes sense. So guys, please remember, I know I keep repeating, so please remember that formula, Tn equals to A times R to the power of n minus 1, okay? For these previous questions.